Hello students, I am Pushkar, Master Teacher in Chemistry at Vedantu. I am discussing JEE Advanced 2019 Chemistry paper. So the very first question in the paper 1 belongs to the surface chemistry chapter, and in the surface chemistry chapter it belongs to the concept of micellization. So let us see what was that problem and how to tackle that problem. In this problem, you can see that molar conductance of a solution, the variation of molar conductance of a solution of sodium stearate is asked how it is varying with under root of C. And four options are given, and in every option, CMC's concentration CMC is marked. So the first question is, the first way to approach this problem is, first we have to understand what is CMC. So as we know, CMC is critical micellar concentration, minimum concentration above which micellization starts. Okay, so before CMC, micellization will not start. That's very important, okay, to understand this problem. Suppose you're adding, suppose A is sodium stearate molecule, and if you're adding it, then this A is going to accumulate, and N of A can join together to form a micelle, where N is the total number of stearate molecules which is forming a micelle. Of course, this N is a variable. This can be 1000, 2000, maybe 1500, but this is how we can describe a micellization process. But this takes place only after we reach the micellization concentration. So if you're adding A into the water, what is happening? You're adding A into the water, then most of the A are like undissociated ions. And here they behave like a strong electrolyte. They behave like a strong electrolyte. And if we talk about a strong electrolyte, how a strong electrolyte molar conductance changes with concentration. So we know this graph. It's a very famous graph which you studied in electrochemistry. Under root of C versus this graph for strong electrolytes is a straight line. So we expect this behavior from sodium stearate in the limit of low concentrations. Low concentration, suppose critical micellar concentration is suppose CMC is suppose 0.5 m. So we can expect this behavior in 0.1 m, 0.2 m, 0.3 m, 0.4 m till 0.5 m. Okay. So up to that point, the lambda m will decrease as the concentration will decrease. So as you increase the concentration, it is decreasing, and the reason is very, a famous reason that ionic mobility is decreases, or we can say that when concentration increases, then positive and negative ion kind of surround each other, and they find it very difficult to move faster. But as CMC is reached, now situation is changed. As soon as we get to the CMC, now what is happening? Most of the soap molecules you are adding, most of the soap molecules you are adding are going to form now micelle. And in the micelle, they are going to get what? Associated. And if they are associated, the conductance will decrease. In fact, you can practically think about it that this not contribute at all. This is not contributing at all to the conductance. It's like an acetic acid molecule, like an acetic acid undissociated form. Though micelles do have slight amount of conductance, but practically very, very small value. So under these situations, what's going to happen? You're adding solute into it, but still it is not contributing to the molar conductance. That means with increasing concentration, molar conductance is going to decrease very sharply. And in fact, the behavior looks like a weak electrolyte. It will look like this, okay? But in this examination, in this options, you don't have such option. You have instead an option in which two straight lines are formed. So we have to believe that only this one is the possible answer. Okay, so if you search for the possible answers, you will find that A is the most appropriate answer. Sorry, C is the most appropriate answer. And you can rule out A, you can rule out B, and you can rule out D. So that is a very interesting problem. Let's summarize this problem, and we can say that as the concentration of sodium stearate increases beyond CMC, stearate ions get clubbed together and form micelles. This abruptly causes the concentration of the current carrier ions to decrease and thus molar conductance decreases. So I hope that you understand the whole process, and for stay tuned for discussions of other questions in this paper, and thanks for watching.